Hello everybody, my name is Bhavdeep Patel and I welcome all of you in our video number 4 of chemistry. You have already seen video number 1, 2 and 3 which is related to the 1 to 30 elements. In our video number 4, today we are going to discuss acid-base concept. You have already learned in the 10th standard, but today we are going to revise all these things. Let us first discuss some basic definitions or some basic characteristics for acid and base. So, acid. What is acid? Or what are the characteristics of acid? Number 1. Acid are sour in taste. Second, acid turn wet blue litmus paper to red. Then, third characteristics. Acid plus base means reaction of acid and base gives us salt and water. Here is the example. Acid is HCl, hydrochloric acid. Base is NaOH, sodium hydroxide. When they react with each other, from here we get Na and from here we get Cl, which makes NaCl. The remaining things H and OH means two hydrogens are there, will make H2O. So when acid and base reacts with each other, they give salt and water. Next, last, reaction of acid with metal produce dihydrogen gas. The formula of dihydrogen gas is H2. Okay, acid, HCl, hydrochloric acid, metal, sodium. When they react, produce dihydrogen gas. Number of hydrogen atoms are 2. We have only 1. Coefficient is 2. Number of chlorine atoms 2. On right hand side is only 1. So before that we are going to put 2 coefficient. Number of sodium metals becomes 2 times. Here is only 1 time. So we are going to multiply it by 2. So these are some characteristics for the acid. Now for base. Let us discuss some characteristics of the base. Number 1. Base are bitter in taste. Right? Second one. Base turn wet red litmus paper to blue. Third. Reaction of base and acid produce salt and water. Here is the example. Base NaOH, name is sodium hydroxide. Acid HNO3, name is nitric acid. When both of these react with each other, from base we get sodium Na. From here we get nitrate. It gives us NaNO3, sodium nitrate, and OH and H produce water, H2O. Next, reaction of base with metal also produce dihydrogen gas and salt. Base sodium hydroxide, NaOH, metal zinc produce dihydrogen gas and Na2ZnO2, and the name of Na2ZnO2 is sodium zincate. Let us balance the chemical reaction. Number of hydrogen atoms, number of sodium atoms, and number of oxygen atoms all are twice the time. So let me multiply here by 2 will make sodium 2 times, oxygen 2 times, and hydrogen 2 times. So this is the balancing of the chemical reaction. Now let us discuss some defines for acid-base concept, in which we are going to discuss 3 concepts. Number 1, Arrhenius concept. Number 2, Bronsted-Lowry concept. And number 3, Lewis concept. Let us discuss first of all Arrhenius concept. According to Arrhenius, which kind of substance are said to be acid or which kind of substances are said to be base? Let us discuss the defines. According to Arrhenius, the substance which dissociates to give H plus ion in water means substances which dissociates in water and gives us H plus ion are said to be acid. If you are going to add hydrochloric acid or HCl in water, it dissociates to give H plus ion, which means it is acid. Base. The substance which dissociates to give OH minus ion, mean hydroxide ion, in water are said to be base. Here is the example. Sodium hydroxide dissociates in the water, gives Na plus OH minus. So OH minus is donated here. It is said to be base. So this is the definition of Arrhenius concept of acid and base. So now let us discuss two more define the terms. First, that is Arrhenius concept. Second, Bronsted-Lowry concept. And third, Lewis concept. The second one, Bronsted-Lowry concept of acid and base. So what is acid according to Bronsted and Lowry? The substance which donates H plus ion, which means proton, is said to be acid. Base. The substance which accepts H plus ion, which means proton, is said to be base. If any substance donate a proton, is said to be acid. If any substance accept H plus, is said to be base. We have example here, hydrochloric acid and water. When we mix both of them, the arrow is reversible, which means the reaction is moved from left hand side to right hand side and from right hand side to the left hand side. Now HCl, when added in the water, it dissociates into H plus and Cl minus. Here is the Cl minus, which means H plus donates. If H plus is donated, then HCl is said to be acid. In the case of water, there are only two hydrogen atoms. But when hydronium ion is formed, there are total 3 hydrogens, which means H plus is added over here, accepted. So water is said to be base. Now, third one, Lewis. Arrhenius and Bronsted-Lowry gives definitions on the basis of H plus and OH minus. Either it may be donated or accepted. But scientist Lewis gives us acid-base concept having the main base of pair of electron. Let us discuss definitions. Acid. The substance which accept pair of electron is said to be acid. If any substance which donate a pair of electron is said to be base, we can clear the definition by the following example. In the case of NH3 and BF3, the NH3 contains nitrogen and BF3 contains boron as the central atoms. Nitrogen donate a pair of electron to boron. So in ammonia, or ammonia is act as a base, while BF3 accept a pair of electrons, so it's said to be acid. Here the arrow is from nitrogen to boron, which means arrow is from donor to acceptor. So what we call ammonia as a, when it donate a pair of electron, base. So NH3 is base and BF3 is acid. Now after discussing acid base concept, let us discuss a small point of Michael Faraday. Michael Faraday. According to Michael Faraday, or we have already practical out it, where the electric current pass through distilled water. Through distilled water, when we pass the electric current, negligible current is passed from the distilled water, not from the regular or tap water. if we add small amount of sodium chloride into distilled water, and when we are going to pass the electric current will pass easily because it contains Na plus and Cl minus ions, because you know that electric current is conducted through the ions only. If we increase concentration of sodium chloride, if in the first case we have added only 1 spoon, in the second case we are going to add 2 or 5 spoons, so more electric current will flow. Michael Faraday classified such kind of substances as electrolytes. Are of the two types. Two types of electrolytes are there. Number 1, strong electrolyte, and number 2, weak electrolyte. Now let us define what we mean by strong electrolyte and what we mean by weak electrolyte. Strong electrolyte, the substance which ionize completely, in the bracket 100%, are called strong electrolyte compounds. Weak electrolyte, the substance which ionize partially, which means just 2 to 3%, are called weak electrolyte compounds. We have example for strong electrolyte: sodium chloride, hydrochloric acid, potassium chloride, and sodium hydroxide. While in the case of weak electrolyte, we have examples like CH3COOH, acetic acid, NH4OH, ammonium hydroxide, which means the strong electrolyte ionized completely 100%, while weak electrolyte ionized partially 2 to 3%. So this is all about the video number 4, which is related with the concept of acid base, definition of acid base, and some of the small concept about the Michael Faraday's. Thank you for watching my video.